531. 531 is really an overview of solving quadratics. What does it mean to solve a quadratic? And that's what, we did graphing, we did factoring. Now we're talking about solving quadratics. And when we solve a quadratic, we need to we need to go back and think about what it meant when we graphed a quadratic. When we graphed a quadratic, we found the vertex, we had an axis of symmetry, we did domain and range, but here's an example. Oh, great, got that on video. Maybe I can edit this out. Just dead pen, worse than dead. All right. Y equals x squared minus 4, for example. 1, 2, 3, 4. The vertex is at 0, negative 4. We have roots at positive 2 and at negative 2. You need to copy this down and have this in your notes, right? You should be able to graph that. It's in vertex form, right? You know that the vertex is at 0, negative 4. You know it opens up because A is positive. And then we found all of these things. We found these 2 points, right? We found them with a T-chart. We looked at the graph. The graphing calculator will graph it for you. You can find them that way. But those 2 points we said were called 4 different things. They're called zeros, they're called roots, they're called solutions, and they're called intercepts. So when we say solve a quadratic, I could say solve and find the zeros. Or I could say solve and find the roots. Or solve and find the solutions. Right? Or solve and find the intercepts. It is where the graph crosses the x-axis. And remember, this graph here happens to cross at 2 places. It doesn't always have to cross at 2 places. It could cross at 1 place. Right? It could look like that. And we have different solution choices. We can say that it has 1 real solution. We could say that it has 2 real solutions. But the third choice is 2 imaginary, which means it has 0 real roots. Okay? What do those graphs look like? They don't cross the x-axis, they look like this. They go up or they go down. They look like that. All of that should be in your notes. It's a refresher. What do quadratics look like when we graph them? How does that correspond to what we're finding? Today, when we find roots, what would that mean the parabola would have to look like? Okay, and we'll keep touching on this learning target. And I'll keep saying, okay, the roots are plus or minus 2, like they are in this one. What does that mean the graph would have to look like? Thank you. All right, questions on this? I just wanted to talk a little bit about 531, about solving quadratics. What would the roots look like here? Well, it could be something like x equals plus or minus 6i. That's an example. Write that down. Over here, the answer could be x equals 2 plus or minus 2i all over 3. Right? That's an example answer that it could look like when it's complex. What does I stand for? Imaginary. It's an imaginary number. It equals the square root of negative 1. We'll talk more about that later. But roots can be 2 real roots, like 2 and negative 2. They can be 1 real root. What's the root here? What's the 0 here? What's the answer here? X equals what? You can look at the graph and tell. X equals what? Negative 4. X equals negative 4 because that's where it crosses the x-axis. Okay? So it can have 2 roots. It can have 1 real root, I should say. 2 real roots and 1 real root. Or it can have 2 imaginary roots. Write this down in your notes. Imaginary roots always come in pairs. Imaginary roots or imaginary solutions always come in pairs. It's always plus or minus 6i. Or it's positive, positive and negative 3i. Or it's like this one. 2 plus or minus 2i over 3. That's 2 roots there. That's 2 plus 2i over 3 and 2 minus 2i over 3. Okay, so that's 2 roots and that's 2 roots. Even though it's written combined, that's 2 roots. All right, questions? All right, so now let's switch gears and talk about